Hello and welcome to today's lesson on endothermic and exothermic reactions. This will be our first lesson in our heat unit. In our last unit, we looked at chemical reactions. If you will recall, one of the indicators of a chemical reaction is a change in energy. In this unit, we will be looking at how and why, the hows and the whys of energy changes in chemical reactions. We will then look at how a change in energy will affect the physics of the object. And finally, we will combine the two to see how energy changes in a chemical reaction can be used. In order to understand how energy changes can occur, you need to understand that there is stored energy in all matter. Some of the energy is stored in the motion of the tiny particles, atoms and molecules, that make up a substance. We will learn about this when we learn about temperature. Some of the energy is stored in the bonds that are holding molecules together. This is called chemical potential energy, and we will study this in detail. In chemical reactions, chemical bonds are broken and new ones are formed. Since these different bonds may store different amounts of energy than the old ones, an energy change will often accompany a chemical reaction. Endothermic and exothermic reactions. When dealing with a chemical change, there are two possibilities that can happen. The chemical change can give off energy to the surroundings, or the chemical change can absorb energy from the surroundings. When a chemical change gives off energy into its surroundings, it is said to be exothermic. An exothermic reaction will feel hot to the touch, since it's giving off energy to the surroundings, which will include your hand. Since exothermic reactions give off energy into the surroundings, the products of the reaction have less energy than their reactants did. A good memory mnemonic to help you remember exothermic reactions is that the energy is exiting the system. As it exits the system, you feel it as heat. When a chemical reaction absorbs energy from the surroundings, it is said to be endothermic. An endothermic reaction will feel cold to the touch, since it's absorbing energy from its surroundings, including you. Since endothermic reactions absorb the energy of the surroundings, the products of the reactants will have more energy than the reactants did. A mnemonic to help you remember endothermic reactions is energy enters the system. The energy that enters is the heat from the surroundings, making the reaction cool. So some examples of endothermic or exothermic processes. So an endothermic process would be the cooling of ice, the vaporizing of alcohol, or ice packs that you would use in sports. Examples of exothermic reactions are thermite, which is a very energy-intensive process, which is hot enough to eat through metal. The setting of concrete, or combustion reactions like burning propane. Identifying exothermic and endothermic reactions. When performing an experiment, it can often be obvious whether it's exothermic or endothermic. When a reaction is written, however, unless you know the reaction personally, you'll need to know a way to figure out if it's endothermic or exothermic. For example, C3H8 plus O2 gives us CO2 plus H2O is the chemical reaction for burning propane. Since you know that many people burn propane to provide heat for their barbecues, you could probably correctly guess that it's an exothermic reaction. But what about the reaction of magnesium plus silver chloride gives us magnesium chloride plus silver? So that reaction, magnesium plus silver chloride, gives us magnesium chloride plus silver. So to indicate whether a reaction is endothermic or exothermic, the energy can be included as part of the reaction itself. The standard unit for energy is the joule, or J, although many reactions in many reactions, the energy change is large enough that we can use the kilojoule, or the kJ, which is 1,000 joules. When writing the energy in change in a reaction, it can be written one of two ways. It can be written into the reaction like a reactant or a product, or the change in energy can be written after the reaction, as it is indicated by the delta H. That triangle is a sign that means change. It's called delta, and the H stands for energy. In an endothermic reaction, the delta H is positive, as the system is absorbing energy, it's gaining energy. In an exothermic reaction, the delta H is negative, so it's losing energy. So we're going to look at a few examples here. This is going to be fairly similar to what your assignment will look like. We're going to decide if each of these is endothermic or exothermic. So our first reaction, we can see that the energy is a product. So the energy is exiting the system, so that's an exothermic reaction. Okay, in the second reaction, we can see that the delta H is positive, so that it is the reaction is gaining energy, so that's endothermic. Okay, same with the third reaction, it's a positive, so it's going to be an endothermic reaction. Okay, reaction number 4 has a negative delta H, so it means it's losing heat into your hand, so you can feel it, it's exiting the system, so it's exothermic. Number 5 has energy as a reactant, so that means it's entering the system, so that's endothermic. Number 6 has energy as a product, which makes it exothermic. Number 7, using electricity to split water into hydrogen and oxygen. So this isn't giving us the example of heat, it's just giving us the example of energy. So the energy is needed to go into the reaction to cause the reaction to happen, which means it's going to be endothermic. Okay, number 8, using heat to decompose ammonia into nitrogen and hydrogen. Again, the heat is going into the reaction, it's needed for the reaction to take place. So again, this will be another endothermic reaction. A campfire gives off a lot of heat, so that's going to be exothermic, as the heat's exiting that system. And dynamite, to go through a tunnel, to tunnel through a mountain. So the dynamite is releasing a ton of energy. So again, the energy is exiting that system. So we'll say that is an exothermic reaction. All right, thank you for sticking through today's lesson. We will see you tomorrow in class.